Hi friends, already we have seen what is matter, what is the physical nature of matter, what are the characters of matter, particles of matter, and in which states all the matters are existing. Here, one more question arises, that is, that states are solid, liquid and gas. Can we change the state one form from to another? If yes, how we can change? Here we have two methods to change the state from one to another. One is by using temperature and second one is by using the pressure. First one is we are going to deal about how we can change the state from one form to another form by using the temperature difference. Before that, we have to know what is temperature. Now here I am going to take two metal blocks. I am maintaining the temperature of one metal block is at 120 degrees Celsius and another one is 110 sorry. I am going to maintain this as 60 degrees Celsius. Now I am going to touch both the blocks by using a hand. Can you say which one is harder than? Now easily we can say this 120 degree block is more harder than this 60 degrees Celsius block. Now I am maintaining this second block 80 degrees Celsius. If you touch by hand, now you can say this block is having more hot. Now I am maintaining 110 degrees Celsius. Now can you compare? Now your perception will say, so two blocks will have same kind of temperature. So there is a need to find this temperature difference. So we have to find one meter, that is thermometer. How this thermometer work we'll see later. Now we can move to the concept. By using the temperature, we can change from one state to another. What is temperature? From this activity we can say that temperature is a measure of hotness or coldness of the object. We have to differentiate between two hotter objects. Which one is colder or which one is hotter? That measure we can say it is a thermometer. It is a property of the matter. Now I am going to take some solid ice cube in the beaker. I am maintaining this solid cube at minus 10 degrees Celsius. Now this temperature of the solid block is minus 10 degrees Celsius. Now I am going to add some heat into that. What will happen? The temperature of the solid cube will increase. Let we know because we are adding the heat. So the energy is being supplied. As the energy is being supplied, that solid cube will absorb all the heat supplied and it will increase the temperature. And up to that temperature, it's going to increase. That we have to find. Now I am putting the thermometer inside this. Now it's showing minus 10 degrees Celsius, and after the addition of heat, there will be the stage at which the solid cube melts and forms liquid. What is that stage? And how this stage will become? And when the stage is reached, how the particles are changed from solid to liquid? If you see some portion of this solid cube, the particles of this solid cube is arranged in a regular manner in closely packed. After the heat addition, there will be the stage at which the force of attraction will be overcome by the heat addition. This heat addition will break the force of attraction. So the force of attraction will be lesser than the previous case. So the fixed state, the particle will move freely now than that of the solid state. So this stage will be reached at a 0 degrees Celsius. Whenever you are adding the heat from minus 10 degrees Celsius, it is increasing to 10 degrees Celsius. At the 0 degrees Celsius, that ice cube is going to melt and form the liquid. That point we can say it is a melting point. and it should be happen in the atmospheric pressure. In the atmosphere, what is atmospheric pressure? We will see later. This is the state. At 0 degrees Celsius, this solid cube is going to melt and form the liquid. Because why? That force of attraction will be lesser than that of the solid state. Now one question arises. Now it is in the 0 degrees Celsius. 0 degrees Celsius state is reached and the thermometer is now reading at 0 degrees Celsius. Even after I am adding more heat to the ice cube, still the 0 degrees Celsius is there. There is no change in temperature, but there is a change in the formation of liquid. Till the ice cube is going melting and forming into the liquid, but there is no change in the temperature, that is showing 0 degrees Celsius. Then where all the heat we are supplying will go? We are adding the heat, but there is no change in temperature. Then where this heat is going? Because this heat is hidden into the system. That heat we are saying latent heat of fusion. How this heat is being utilized for the formation of liquid state? That the latent heat is being utilized by the particles of the solid cube and to form from the solid to liquid. Because this heat is going to utilize the formation to break all the force of attraction of the particles, and it's freely moving. That is the reason that the heat being supplied at the 0 degrees Celsius is hidden into the system, so we can say this is a latent heat of fusion. The definition, if you see the definition of the latent heat of fusion is, what is the heat required to convert 1 kilogram of mass of fluid or anything, mass of solid, into liquid state? The heat required to convert 1 kilogram mass of solid into liquid form. That heat is latent heat of fusion. Now see, now all the temperature, all the solid cube is being melted and form the liquid at 0 degrees Celsius. So at the 0 degrees Celsius itself, the solid cube is melting and formation of liquid occur. Now the heat addition is happening. Now even though you can add the heat, what will happen? And after the formation of all the liquid, then it is increasing. The temperature of the liquid now is increasing. 10 degrees Celsius, 20 degrees Celsius, 30 degrees Celsius, 40 degrees Celsius, and 100 degrees Celsius. When the level is reached, the temperature is reaching to 100 degrees Celsius, there is no change in temperature. What will happen? At this state, that liquid will form the vapor. This is known as water vapor. At this stage, at this temperature, the formation of water vapor from this liquid state is known as boiling point. As in the case of latent heat of fusion, same here at 100 degrees Celsius, even though you supply the more heat into the system, there is no change in temperature, but still it's happening. The formation of vapor occurs from liquid to vapor. So where does this heat go? This heat is being utilized to break all the forces in the liquid state and to become the vapor state. This heat is known as latent heat of vaporization. So you can say, what is latent heat of vaporization? The amount of heat required to convert 1 kilogram of liquid into the vapor. That is latent heat of vaporization. So what is the factor which affects all these cases is temperature. By changing the temperature from 0 degrees Celsius to 100 degrees Celsius, we are changing the state from solid to liquid and liquid to gas. And how we can know what is the thermometer and how the thermometer works. Now I have a thermometer. Here I am using the liquid alcohol. Nowadays you can see more in thermometers, you can see the mercury. Why we are using this type of liquids in thermometer? Because of it's having, if you heat this liquid, it will expand very high. The expansion is having, as it is having the expansion property, we are using this type of liquids in the thermometer. Because whenever you add the heat into this tip, it should expand when compared to another type of materials. Okay. So here, if you take this is a thermometer, now first, why we are taking the 0 degrees Celsius is the boiling melting point and 100 degrees Celsius is the boiling point. Why we have to take it? First thing, we are considering the water because water is a common liquid. This is available everywhere in the earth, also in the universe. Okay. So I am taking the water and at a particular temperature, the water is melting, the solid cube is melting and the formation of water is occurring. This point I am considering as a 0 degree Celsius because even any measurement we need the reference point to start with. Otherwise we can't measure, because what is a measurement? We have to compare one unit from the other. Here I am taking 0 degrees Celsius, that the common fluid, the melting point of common fluid, water, that melting point I am taking as a 0 degrees Celsius. So I have more. If you see, now if you see the thermometer, first before the innovation of the thermometer, how we can measure? So I am taking, this is a 0 degrees Celsius, this is the melting point. So first this is a reference point. And I know what is the boiling point. At a particular temperature, the water is boiling and making the water vapor. That temperature I am marking, the same time I am marking at 100 degrees Celsius, and that is boiling point. Okay. So I have taken two reference points at 0 degrees Celsius melting point and 100 degrees Celsius is the boiling point. Now I am going to divide this line into the 100 points. From the 0 degrees Celsius to 100 degrees Celsius, I have divided this level into 100. Each unit, each division will give 1 degree Celsius rise. And another one is 2 degrees Celsius, 3 degrees Celsius, like that. If you put the thermometer, if you keep the thermometer in the beaker, and at a particular level, at a particular temperature, it will show maybe here, also here, in the liquid state. At the boiling point, this will show this 100 degrees Celsius mark. And even if you add the heat into the system, there will be no change in temperature, still it will show the 100 degrees Celsius mark. Okay. In this thermometer, you can see the red color liquid we are using is alcohol, because it's also having the expansion property. Okay, thank you.